All right, hello. Welcome to our very colorful RGB computer. Uh, we put a lot of work into creating this little small like viewing area. Uh, so to begin with, here's our program counter and our program memory. Um, we have everything connected together as well as an additional emerald wire here that prints out whatever's in val E or the output of our ALU. Uh, we also have, I'm sure you've seen our ALU, so there's that. Our output typically will be shown in bits here, but we also have our hex display back here that'll show it, but that hex display only goes up to 8, while we can go up to 15 with this bit display, so we have both here. And to prove that this is connected to our ALU output, so we're going down here, we use the schematics from our mux to kind of figure out what gets displayed on the hex. And we kind of had this like program memory type of hookup going on here. So then now we go to the output back here with our read and write wires all the way around here. So we have everything kind of just hooked up to our registers, our muxes, all that jazz. And primarily we'll be using, so our program uses, it technically uses register 0 here, but since it's kind of directly hooked up to our output, we kind of shifted like everything over to 1 and 2 is where most of the stuff gets held. So then if we go back to the beginning here, let's show how we can start this computer up. All right. So we're back here. Our program is only about 1, 2, 3, 4, about 5 lines of code here, and it loops. So in our clock, once it hits this 5th line here, it's going to start back at the beginning. And the way that we control sort of having it not reset is by just disabling this first line after that first loop. So once it clocks through this, we turn this lever off here to disable the line from running. So then it's going to go through, and then this first line here is not going to execute. It's going to go on to the next one, and then it's going to, that recursion happens for our Fibonacci sequence. And then we also have this lever here that force restarts our program. So this will force the loop to start back at that first line. So if you wanted to start it, you'd have to make sure that this is on, and then this lever is on. So you want both of these lamps lit up. You'd want to wait a few seconds. So for the redstone power signal to course through the whole thing. And then you're gonna flip this lever off and wait for the clock to happen so that it hits the next line like that. So then the second line's gonna grab. So yeah, line 0 is gonna set our values in register, well, in val A and val B to 0 and 1. Then it's gonna move the value in val B into register 1. And we're gonna add the two together, A and B, and then store that result into register 2. And then we're gonna store the value in register 2. We're gonna feed that back into value B as our next item to add. And we're also going to grab the value that was in register 1, which is B's old value. That gets put into value A. And then we loop again, and then they get added together recursively. So that's running. I think, yeah, we're a few ways into this right now. Let's restart it again, and then we'll take a look at the output show what's going on here. This will take a while. And Lawrence, if you want, you could show what torches we have enabled in our program memory. Let's see here.
Yeah, okay. So
yeah.
Let's see.
I think we have a few torches back here for this first line that kind of sets everything, and then
yeah,
we marked everything up with glowstone that shows where what wires are powered when. All right. All right, yeah, okay, let's head down to the computer again, and we're going to restart it, and we're going to take a look at what our outputs are going to be. So I'm going to start the clock now. And to reiterate, our creativity for this lab is the clock and the hex display. So our first digit is 1 in the Fibonacci sequence. Now, as it's going through each time, it should print out the result of adding. So the next number should be printed at about this third line here, I believe. Yes, this is where the addition takes place, and you would see the print occurring. And there's a small quirk with our program where it's going to show the current value and then the value right after. Before that, it gets a chance to clock. Our program gets the clock. So as you're looking at the display, it's going to flicker from 1 to 2. And then when it gets to 2, it's going to flicker from 2 to 3 and then turn off. So it's going to show the current value and then the value that follows for each iteration of our loop here. And we haven't been able to figure out how we could only just show the current value at this stage, at this line of our program. So that's sort of just something to point out. All right. So it should now be showing 2, and then that's going to change to a 3. Yep. And because of how we have everything up, our clock time is about 8 to 9 seconds. Okay, so the next loop is coming around here. So now we're going to be seeing 3, and then that's going to switch over to 5. Huh. I didn't see that change, but if you paid attention to the bits, that was showing 5 earlier, I believe. So hopefully in this next loop, it's going to show us 5. Yep. So 5, there we go. And then 8. And then it loops. And then after 8, our hex display can't show the next number in the sequence, but our bit display can. It'll show 13 here. So it starts at 8, and then it's going to light up, I believe, these first 2 here, or these 3. Yep, 13, there we go. And that's the highest we can get our Fibonacci sequence to go, because we're only working on 4 bits. All right. Ooh. We also have a parkour course here right next to our map. Right. I think we can cut the video here now.
Gotta go through the parkour course.
Or not. Yeah. If you can like clip through certain awkward parts, you can do that too. Yeah.
Yeah.
Mm.